Welcome to CK Supply's mini weld series. Steve Neubauer, CK Supply, and we got Taylor over here to kind of help out with our series that we got going on this week or for this month. We're going to be talking a little bit about MIG. We're going to start off with MIG equipment, kind of the pros and cons of going to different styles. We're going to talk about the different transfer modes you can achieve, and then later on we're going to apply those to some of the different videos later on. So right behind me here, I got three machines. We have a Delta Weld 350 with the wire feeder. We have an old Regency 250 with the wire feeder on top, old guy, and then we have a MIG 255. So MIG is an old thing. It's been going on since 1940s. Is when kind of introduced. This guy right here is one of the newer versions of the MIG machines at the time, and this machine's a transformer base. So you have a transformer and an inverter based machines. You got your power source here, the wire feeder, input cable, weld leads, and your MIG gun. So this one is a transformer, like I said. Takes 50 to 60 hertz. Takes a lot of power to work. It's not really efficiency, or the efficiency of it is not very good when coming to power. So to the left of me, we got the MIG 255, and I'll let Taylor kind of talk about this. So Taylor, what do we got going on here with this MIG 255?
So yeah, we got the 255 here. It's pretty much an all-in-one unit. It comes with the power cable already attached. You still get the MIG gun, your ground cable, but the nice thing about this is that everything is contained inside. You have the wire feeder on the inside, power unit, all together, so easily portable, ready to go, just plug and play.
So what's kind of the main differences that we run into with the industry with an inverter all-in-one machine and the Regency, or even this Delta Weld where you have the power sources and the wire feeders on top? What's kind of the...
So the biggest difference is going to be, that we can tell, is that the wire feeder is detached on these two units here, and it's internal on here. So the pros and cons to that is that this is easily portable, moving around, but as soon as you have to get away from the power source, then you're going to have a longer power cable, which creates a hazard. Somebody runs over it, it's got nicks and cunts. You get hurt some way. So the nice part about these two is that you can actually detach the wire feeder and run it farther away from the power source, eliminating those risks and giving you more portability with it.
And we're going distance by using the weld cables, right? So we can have the power source right at the input box. So we keep the power source there. We can have a weld boom or a swing or some cable tracked where the wire feeder can be moving across. And like Taylor mentioned earlier, someone can run over that input cable, so we want to keep that hazard to a minimum. So if that cable were to get cut, nicked, ran over, whatever way, someone's out there welding, got an arc going, and it's cut, now you lose power because that is a secondary output. So all that power is gone. It's maintained at the machine back at the input box, and it no longer is in need of power. So what about the industry, Taylor? Where do we usually see these machines at?
So these two guys are going to be smaller units. They're the 240 power supply. So that's good for light fabrication, automotive, small industrial stuff. That's where these two are going to come in handy. When you get into bigger fabrication, heavy duty industrial, you're going to go to the bigger unit. You're going to have more power, more capability to do thicker materials, and it's more useful in those applications.
Perfect, great. So that's a take on our little difference between the inverters and DC transformer machines. See you next time.